Richard James will present Substitution Tutorial 2. And there we have another expression and the particular values that we need to substitute for the variables L, M, and N. There we have our template, and in their respective places we have L, an occurrence of N and another one, and of course we will finish up by substituting M into its place and another place. Only in the numerator we have something special, which is the product of a negative times a negative. So negative 3 multiplied by negative 2 is equal to positive 6. We may treat all the other ordinarily as if they are not enclosed in brackets. So why do we include the brackets if at the end we will treat them as if they are not included or they are not necessary, or as if the numbers are not enclosed in brackets? Why do we include them? Because we include them for eventuality. When we do not need them, then we do not use them. But let's say we need them, but let's say that we need them and they are not there, then it will be easy for us to make a meal of the problem. And as they always say, it is better that you have it and not need it than you need it and you do not have it. So there we have 4 plus 6 divided by negative 7, treating the denominators as if we do not have them enclosed in brackets. So we have a negative 3 minus 4, that's a minus 7 or a negative 7, and we have negative 10 over 7. Brackets are always included in the template because of eventuality. So brackets are always included in the case of any eventuality. However, when the situation makes their inclusion insignificant, we may dissolve them. So use them in the case of any eventuality. So make sure you always have them just in case you need them, ensuring that you do not find yourself in a situation in which you need them and you do not have them. A squared multiplied by all of 2b minus c, and we just A into its slot right there. What about b? Only 1 for b and only 1 for c. 4 squared is 16, and what do we have here? 2 times negative 3, that's a negative 6. But let's see what the instruction says. Square 4 and make use of 2 times negative 3 is equal to negative 6. The other inner brackets may be dissolved, which is this one, negative 12. So we may eliminate this bracket because it is not necessary. But the one that we have here would have done its work already. 2 multiplied by negative 3 rather than 2 minus 3. So 2 multiplied by negative 3 is negative 6. So we have square 4, 16. 2 times negative 3, negative 6. And we have a negative 12. And when we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added, and that is pertaining to the numbers that we have inside of this bracket. We have negative 6 minus 12. Add the values and the answer will take the same sign. Negative 288. Finish by multiplying the positive and the negative numbers, which is 16 times negative 18. That gives negative 288. This one is flat, just like the one before. No denominator, no fraction, as a matter of fact. We have that flat expression, and we will substitute the first thing first, L. Then we have the second, M, and then M. Then no doubt the value of N. And what do we do? With or without the brackets, 3 minus 7 will be the same, which is subtract the smaller from the larger, and the answer will take the same sign as the larger. They have opposite signs, and we may use the rule of thumb. When we have different signs, we find the difference. Difference. So 3 is a positive, 7 is a negative. Find the difference, and the answer will take the same sign as the larger one. So if you tip your scales, you put in your 3, you put in your 7, it will tilt over to the direction of negative 7 being negative. So the result will turn out to be negative. So it's a negative 4. And of course what we have here is negative 2 times 3. Negative 6 times negative 4. That's a positive 24. In the end, the product of two negative numbers is positive. We need to find the value of P if 3 is a root of the equation. A root of an equation is a solution of the equation. This means that the value that is considered to be a root of the equation satisfies the condition. We have a quadratic expression that is equated to 0. The expression is an equation in x. That means that x is the unknown of the equation. 3 being a root means that since the expression is an equation in x, if we replace x with the value of 3, the expression on the right that contains x will still be equal to 0. But when we put 3, x will be there no more. But since 3 is a solution, it means that if we replace 3 with x, the expression is still equal to 0. So 3 being a root means that since the expression is an equation in x, if we replace x with the value of 3, the expression on the right that contains x will still be equal to 0, which is the requirement of the equation. According to the equation, the expression on the left should be equal to 0. X equal 3 being a root will cause the expression on the left to be equal to 0, satisfying the equation. So according to what we have here, 5x squared minus px minus 18 is equal to 0. X being equal to 3 is a root. So if x equal to 3 is a root, when we put 3 here, substitute 3 into this equation, then the result on the left will still be equal to 0. And that is what it means to be a root. So if 3 is a root, this is equal to 0. If you place 3 inside here, it is still equal to 0. So the condition is maintained by substituting x into that expression. Therefore, what we will do, if that is the case, is substitute 3 into this expression, and the result should still be equal to 0. So there we have it, equal to 0. Where we see x, 3 is there and 3 is there, maintaining that the expression is equal to 0. That is what it means when we say that 3 is a root of the equation. If we substitute 3 in terms of the otherwise unknown, then the result will still be equal to 0. Now we will simplify. 3 squared is equal to 9. Then 5 times 9 is equal to 45. So 3 squared 9 times 5 is 45. And negative p times 3 is negative 3p. The 18 will return as it is. And if we have an equation with each term being a multiple of the same number, then we may divide that equation all the way through by that single number. We may divide the equation by a common factor of 3 because each one of those terms is a multiple of 3. So divide by a common factor of 3. So 45 divided by 3 is equal to 15. 3p divided by 3 is equal to p. 18 divided by 3 is equal to 6. And 0 divided by 3 is equal to 0. So 15 minus p minus 6 is equal to 0. On the left hand side, 15 minus 6 is equal to 9, and by transposition we have a positive p on the right hand side. So transpose, eliminating the p from this side, we will have a positive p on this side, and on the left hand side we have 15 minus 6 is equal to 9. Then turn the beat around. 9 is equal to p, so p is equal to 9. There we have another expression, and we have our template created in the fashion mimicking the one that we have right here. So what do? Where we see a, we put 4. Where we see a, we put 4. Where we see b, we put negative 2. And where we see b, another negative 2. There's a single occurrence of c not to be left out, and we have that right there. The consecutive negative signs result in a positive, and in the denominator we have negative multiplied by positive is equal to negative. So we will have 4 minus negative 2 to be 4 plus 2, and we will have negative 2 times 3 will be a negative 6. And what do we know next? 4 plus 2 is equal to 6, and 4 over negative 6. What do? 6 in the numerator and 6 is also in the denominator, and those will cancel each other, but we cannot neglect the negative sign. So these 6's will cancel each other, but we cannot neglect the negative sign. The result is therefore negative 4. Nice to see one of these values equal to 0. That makes it easier to simplify the expression. So we have 4 with 2, b is negative 3 right there, and c is 0. And only negative times negative, what we have right here, negative 2 times negative 3, and any number multiplied by 0 is equal to 0 are worthy of note. So what are the things that are worthy of note in this expression? Negative times negative is positive, and any number multiplied by 0 is 0. So this one is gone. So we have 8 plus 6, and hopefully we have 14. No matter. no problem. And what else? And some candidates may be asking, now that one of the variables will be in that index, how will Richard James construct that template? Richard James will construct the template in the same way how Richard James construct templates on a daily basis. Right. So there we have 2 for A. And what is the value of C? 0. And some students are delighted to see that index of 0. 2 raised to the power of 0 is equal to 0. And they will get the answer. Incorrect. Any number raised to the power of 0 is equal to 1. So that is actually equal to 1. Another expression, we will do the same thing. For P minus QR. So for P, we have that. For Q, we have 0. For R, we have -3. And it does not matter because anything multiplied by 0 is equal to 0. Any number multiplied by 0 is equal to 0. And needless to say that 4 times 5 is equal to 20. I hope 4 times 5 is equal to 20 does not baffle any candidate. What about the other one? We have 2r cubed. So we have 2, then r cubed. R is -3. Goes right into there. When we cube a number, we multiply 3 occurrences of that number together, like cube of -3, -3 times -3 times -3. Multiplying 3 occurrences of that number together. The number of negative signs is 3, which is an odd number. The sign of the answer of the cube is therefore negative. Therefore, I think that I've done on a previous occasion somewhat of an explanation on a video that says when we have a negative number, odd powers of that negative number will be negative and even powers will be positive. And then we say all even powers are positive. So we have gone through this before, saying odd powers of negative numbers are negative and all even powers are positive. So when we cube that, we have -3 times -3 times -3 turns out to be -27, and in the end the result is 2 times -27 is equal to -54. And I am sure that as soon as the candidate sees this problem, I know how to cube already. 2 times 27 is equal to 54, and that's all there is to it. Neglecting the fact that when we cube, we are not squaring. When we cube, the answer will take the same sign as the number that we cube. And therefore we have a -27 times 2 is a -54. Finish up with this one that says P is equal to 6, Q is equal to 12, R is equal to 2P squared over all of Q minus 3. There we have our template, and where we see P, we put 6. Where we see q, we put 12. And the simplification of this one is simple. The square of 6, 6 times 6 is equal to 36. And 12 minus 3 is equal to 9. So we have 2 times 36 over 9, which is of course 72 divided by 9, which is equal to 8. But in mathematics, we generally play it safe by, instead of going large, we go small. So instead of saying 2 times 36 is 72, then 72 divided by 9 is equal to 8, we reduce the fraction first by a common factor. So reduce by a common factor of 9. 9 into 9 is 1. 9 into 36 is 4. So instead of multiplying in the end 2 times 36 to give 72, all the multiplication is 2 times 4 is equal to 8. And I am sure that it is easier to do that. So multiply the numbers in the numerator, and we have 2 times 4 is equal to 8. 8 over 1, and any number divided by 1 is equal to itself. Any number divided by 1 is equal to that same number.